So hello students, I welcome all of you on my YouTube channel. So we will see more concept in the complex number in the IIT lecture series. Okay, so we will see how to find the square root of a complex number. So how to find the square root of a complex number? So if we have one complex number like z equals to x plus iy, and we want to find the square root of this z. So, and we have another number z dash, which is a plus ib, again a complex number. So under root of this z, x plus iy equals to a plus ib, because square root of a complex number will also be a complex number. Okay, so now for finding the value of this a and b, we will apply some mathematical operations. So we will do square of this whole equation, x plus iy equals to a plus ib whole square equals to a square minus b square plus 2i ab. Now equating LHS and RHS. So x equals to a square minus b square, and y equals to 2ab, second equation. Okay, so now if we have the value of x and y, then we can easily find the value of a and b, or vice versa. If we have the value of complex number z, then we can find the square root value of this complex number z, which is a plus ib. So I think it's very easy concept. So we will see some examples and also IIT JEE problem also. 7 minus 24i, to find the square root of this number. So if we will use this exact formula, then here x equals to 7, y equals to minus 24. So apply this. 7 equals to a square minus b square minus 24 equals to 2ab. Okay, so after that what we will do, it gets more complicated. So what we will do here, so you apply like ab equals to minus 12, b equals to minus 12 upon a. So 7 equals to a square minus 12 upon a the whole square. So a square minus 144 upon a square. Okay, so a to the power 4 minus 7a square minus 144 equals to 0. So assume a square equals to x square or some other constant m square. So m square minus 7m minus 144 equals to 0. So now this is a quadratic equation. So root of these equations will be m equals to roots of this equation will be, we want 144, so it will be 7 plus minus 49 plus 4 4 is 24, 4 4 is 24, 26 4 is 4, 6 upon 2, 7 plus minus 9 4 3 1 7. So now from this you can find the value of a and b, and after finding the value of a and b you can write the square root in this form, a plus ib. Okay, now if we see the next example, so the next example is minus 2 plus 2 root 3. So again apply minus 2 plus 2 root 3 I equals to a square minus b square plus 2iab. So a square minus b square equals to minus 1 and ab equals to root 3, b equals to root 3 by a. So a square minus 3 upon a square equals to minus 1. So a to the power 4 plus a square minus 3 equals to 0. So assume a square equals to small m. So m square plus m minus 3 equals to 0. Okay, so m will be minus 1 plus minus 1 plus 12 upon 2. So minus 1 plus minus root 13 by 2. So this is your a square. So a will be minus 1 plus minus root 13 by 2 plus square root. So you can find the value of small b also. Understood? So I think it's very easy. So now next we will see how to represent the complex number on the xy axis. So in the Cartesian form, forms, it's origin x and y. So if we have one complex number like z x comma y, so from origin to point A on x-axis it will be x, and from origin to point B on y-axis it will be y. Okay, and the smallest path between O and Z will be like this. So in this way we can represent the complex number. So after that we will see one is modulus and the other is argument or angle. So modulus of any complex number z will be modulus of z will be mod of z. So what will be the mod of z? X plus iy mod. So it will be x square plus y square. Okay, and it is also equals to OZ on this xy plot, because this O to Z will be under root of x square plus y square. So if any objective questions ask that find the modulus of this complex number, so what you do, you will just do the square root of the addition of the individual parts of that complex number. Now what will be the argument or angle? So angle we will assume from here, from the positive x-axis. On the anti side. So arg of z equals to tan inverse y upon x. Okay. So for example, if we have z equals to 1 plus I, then arg will be tan inverse 1 upon 1. So it will be 45. 45 from the positive x-axis in the anti-clockwise directions. Understood? So now you have got the concept of modulus and argument or angle of any complex number z. So here is it. Thank you so much.